Không phải, ông này ông garbage từ lúc mà
Okay, I appreciate everybody joining. I'm going to wait just a couple more minutes here, not too long, but let some more people join. So while people are gathering, does anybody have any questions? Hi, Jeremy. I'm not sure of the question.
My mistake. I was just wondering if you continue to talk after asking if there was any questions.
I haven't heard any.
Okay. I was just wondering if like your mic went out or if it was me, but
Nope.
good.
Okay, so we don't have any questions, so I think we'll just go ahead and get started then. So we left off here. And we're going to start talking, we're in the macros, of course, talking about macro processors. And we're going to take a look now at the macro processor and see, we talked what its purpose was, why we had this, and some advantages and disadvantages, and what's different about a macro processor from an assembler or compiler. So now let's look at some of the details of what makes this thing actually work and how to actually implement these, because it's kind of cool. Here, I'll just kill that. Okay. Sorry, I have another screen over here that's giving me some problems. Just gonna get that out of the way for right now. There, okay. All right, so the macro processor. What it's gonna do, of course, is read the source code just like the other tools are reading the source code as well, but it's looking for those macro instructions. And as you recall, we created two new assembler directives, the macro and the macro end, that will allow us to be able to create and use these macros. So the source, so now what we're gonna have to do is have this part of the tool, that is the macro processor, kind of a front end, if you will, if you want to think of it that way, to the assembler. It'll parse the source code looking for those assembler directives, and then it's going to perform work based upon the instructions that the programmer put between those assembler directives. So the macro processor, as you can see here, is going to be scanning the source code, and once it recognizes the assembler directives, it will then perform its work by expanding the code that the programmer programmed inside the macro assembler itself, and then the work would then go back to the compiler of the assembler to do the rest of its work. Because really all we're doing, as you recall from the discussion on Wednesday, was going through and doing a replacement and expansion based upon the code that the programmer put inside there. Okay, so from this perspective, nothing really fancy. It's just performing this expansion work. It's the details of the expansion work that gets a little interesting, and that's what we're going to take a look at here. Specifically, one of the things that the macro definitions can do is it can just simply copy code. Okay, that's very simplistic, and most of the times it's not good enough for what we want a macro to do for us, but simply it sure could just simply copy code and replace the macro word itself with the new code that the programmer wanted to do. Typically, however, though, we want it to work with variables. What we think of as variables, right? We want it to work with, in this case, some symbols so that we've created or we are creating in our code. And so if we work with symbols, then we're going to need to do parameter substitutions because we're going to be doing operations on those symbols. And so we have to create unique symbol names for each of these parameters. We're going to let the programmer program these parameters. And then when we're doing our code copy, then we have to do a substitution for each parameter, creating unique new symbol names for every one of those parameters that we use. The other thing that we like to do is we like to build more advanced macros that can do conditional logic. And so we're going to look at some conditional expressions that we can build into our macros so that we can do expansions or partial expansions based upon some conditional tests that we might want to perform. And then finally, we are going to, oh yeah, my pointer. I need to change my pointer to something that you can see easier, like that. So finally, the macro instruction defining macros themselves. All right, so let's take a look at these. Okay, so here on the left is you will see how you could write some source code to do a macro. There you have the symbol strg for string. We use macro to say we're creating a macro. And then the programmer programs what they want the macro to do. Store A, store B register, store X register with data 1, 2, 3. And then we have the mend or the macro end assembler directive saying that's the end of this macro, and everything else beyond that now is just regular assembly code like we saw before, or source code, assembly source code like we saw before. So what's going to happen though when we encounter this is that the macro processor itself is going to take the store A, store B, store X, and it's going to create the symbols data 1, data 2, and data 3 that it's going to use to store to A, store to B, store to X, just like we defined up here for the macro. And that's great when we use it the first time. The problem comes when we use it subsequent times, which is why we want to build a macro anyway, because it's typically going to be used more than once. And so if we use it again, store A, store B, store X, we still have data 1, data 2, data 3, then we're just simply using those same variables over and over again, which might be what we want it to do, but probably isn't what we want it to do. We can certainly do that. We can code it this way. So we're always going to use data 1, 2, and 3 for store A, store B, store X, and work with those symbols, knowing when we do this macro expansion that it's going to take whatever's currently in those symbols at that time when we do that macro expansion, and that's what would get copied to the A, B, and X registers. So we can think of a couple of approaches to this, right? One is, and you're probably thinking of subroutines already because we looked at subroutines, we saw how useful they are and how fairly simple and straightforward they are to work with inside of the SIC language here. So that is one way to do this. And if we do that, we could always call a subroutine, especially if we're using those same three variables, right? Or same three symbols, data 1, data 2, data 3. And that would be, in fact, a really easy way to implement that instead of going through all the bother of doing a macro expansion at that point. But if we wanted to work with other variables or other symbols other than data 1, data 2, data 3, then we do need to have a macro processor that can do the expansion as well as being able to generate new symbols for each of those if that's what we wanted to do. We didn't tell it to do that in this previous example, by the way. The way this example looks right here, where we created this macro with data 1, data 2, data 3, it will expand every time using those three symbols because that is how this is actually programmed. We haven't programmed it yet to do symbol replacement. So it would actually do this. So in this case here, yes, you could call a subroutine, it would be simpler. Not only would it be simpler, but it would also generate less code because you would just jump into the subroutine and then return from the subroutine every time you wanted to do that function, that macro function. But if you do a macro instead, it's going to insert those three instructions every time you use that macro, as opposed to calling the subroutine. Clear enough? Okay. Got a hand. Go ahead.
Yeah, I had a question just about using macros and subroutines in external programs.
Yes.
Could using creating these or defining them in an external program and could that almost simulate like a library, such as C has like the standard library that has some of the basics in it? Is that kind of?
Not really. What we saw that was closest to that was when we were working with different control sections. You remember
Okay.
that?
Yeah, I think that's what maybe I meant.
Yeah.
Maybe I misspoke. Okay. All right, cool.
Okay. So if we wanted to work with variable substitution, then what we would need to do is define our macros with those symbols that we want to use for replacements. And so to do that, we would do the macro assembler directive like we saw before, but now we would do the and sign and then the symbol or symbols that we want to do substitution on anytime we do a macro expansion. So we would define those symbols here after the and sign rather, and then we would use them in place in the code instead of data 1, data 2, data 3 like we saw before. We would then use this nomenclature here, this replace me symbol, if you will, and this replace me symbol and this replace me symbol instead of the data 1, data 2, data 3. Now what we can do is we can actually create strings, strg right here, strings with symbols that we want to actually use. And so we could do that this way. And so when we encounter strg, which is now a macro, the first time, we wanted to use data 1, data 2, data 3. The next time that we want to do a macro expansion of string strg, we decided we want to use these symbols, data 4, data 5, data 6 instead. And so what the macro processor would do is it'd say, it would say macro here in min, we're defining the macro with these symbols that are going to be replaced. And then when we go to use that macro, because this is the macro name, strg, so we go to use the macro now, we provided it, because we need to provide 3 symbol names, we provided it 3 symbol names. The first one is A1, the second one's A2, the third one is A3. So we use data 1, 2, and 3. And when we come over here to the expanded source code, you could see that, oh yeah, we do the STA, data 1, STB, data 2, STX, data 3. Then the second time we invoke the macro strg, we're now going to use symbols data 4, data 5, data 6. And that second time we do the expansion, now you can see the data expansion includes STA, but now data 4 instead of data 1. STB is now data 5 instead of data 2, and STX is now data 6 instead of data 3. See how that works? And you could do this with any number of symbols. It's just a list, right? And you're just doing a comma separated list here. And then these names that you're using here, you're going to match them to whatever instruction or instructions. We could have used A1 here and A1 here and then A2 here, or even A3 and not even use A2 if we wanted to. We can program this any way we want to. The key thing, of course, is using this ampersand symbol here to denote that these are the symbols that are going to get substituted during the expansion. Okay, so that's fairly straightforward, I think, but of course we can make things much more complicated because we do fairly complicated things in code. That's why we're writing in code to solve problems that's been somewhat straightforward or somewhat more challenging. Usually the more challenging, that's what we get. That's what we like. So one of the things we could do is we can create arguments based upon their position if we wanted to. Or we could do the keyword arguments. Okay, the positional, of course, is just like we saw with the comma separated list, data 1, data 2, data 3. They would directly get mapped to those first 3 in that order. We could, however, because we programmed the macro, we could go ahead and use keyword arguments and do these in any order we wanted to, which is what you see right here when you get strg and we want to say, we want the replacement symbol A3 to now get assigned data 1, A2 to get data 2, and A1 to get data 3, kind of reversing the order. If we wanted to do that, we could, simply by using this keyword matching list, this keyword argument matching list like this. Okay, so you could do it either way. They're both fine. They give you the flexibility of, you know, writing this like you're thinking, programming your code like you're thinking it, instead of being forced into a strict list order, or you could do it this way if you want to. You've got the capability. Okay, so now let's talk about the macro processors and how we would actually implement these. Okay, so kind of off to the right here, the three data structures that we're going to need to work with are going to be the name tab, the define tab, and the arg tab, which we've seen before, right? So we're going to need to use those to help us implement a macro processor as part of a one-pass processor. So in order to do this, we're going to require that all macros are going to be defined before you use them. And as you recall from the assembly level source code, we were able to create symbols after we use them or before we use them. It didn't matter, but it did go to a 2-pass assembler to implement that, but we determined that was worthwhile, and we did it that way. But for the macro processor, if we want to do it as a 1-pass, and that is really handy, given that you're adding a little bit more complexity now, and you don't want to be adding more and more passes to your assembler if you can avoid it, then you would have to define them first. So we'll make that prerequisite. You must define your macro before you use it. Okay, and then we're going to need a couple of sub-procedures. So we're going to create a macro definition of define and a macro invocation of expand. Then they'll be pretty much just like their names describe them. Being able to define one, being able to expand one. That way, there's no confusion when you're doing the operation about what you're trying to do. Okay, so to do this, we're going to need to build a function called process line, where process line is going to define the macro and then call the macro to expand it. So let's take a look at some pseudocode here for our macro processor, 1-pass. And let's just kind of go down it here. We're not going to focus, since it's pseudocode, focus too heavily on the semantics here, but it's correct. But it's defined this way. Okay, we're going to define expanding to false because we need to define, that is, a macro before we can expand one, right? And we're going to go into this while loop. While we're not at the end assembler directive, we're going to call getLine, and then we're going to call process line. So getLine, we'll come down here in a minute. GetLine is going to read a line of code, and then we're going to call process line to actually do the work. Let's see, did I have getLine? No, we'll come back to getLine later. GetLine's pretty straightforward. We're just going to read a line of assembler code. And we're just going to do that till we get to the end. At that point, we'll break out of this loop and we're out of the macro processor. So what are we doing then for process line? So for process line, what we're going to do is we're going to search the name tab for opcode. Pretty straightforward, right? If there's an opcode, then found is true, and we do an expand. Otherwise, opcode is going to get macro. We're going to test to see if opcode is equal to macro, and if it is, we're then going to define it. Otherwise, we're going to write the source line to the expanded file. Pretty straightforward. Okay, so that way we can, as you can see here, that way what we can do is we can look to see if the macro's already been defined before we try to define it, because we still have to do some error testing. And then, of course, if we're going to expand it, then we don't want to be defining, we shouldn't even have that line of code there to do the define anyway, but we always need a test for that. So that's what we're doing here with this, this code. Okay. So now let's take a look at these data structures. Okay, so what we're going to do is we're going to look here in the name tab, right? And the name tab is going to have a couple of pointers. And you recall back from our examples in chapters 2 and 3 for read buffer. Okay, and read buffer has in some code here for a macro. I'm sorry, read buffer. We had a read buffer before, but what we're going to do now is we're going to implement read buffer as a macro instead of as a subroutine. So what we're going to do then is we're going to define our macro. Okay, so we're going to define tab. We're going to define our macro. So we're going to go here into the define table, and we're going to say read buffer is now going to be defined as a macro, and it's going to have these three symbols that we are going to do substitutions on every time we do an expansion. In device, buffer address, and then reclef. Okay, so we have these three substituted symbols we're going to substitute when we call this, but right now we're defining it. So here's how it's defined. We're going to clear these three registers, X, A, and S, load the T register with this immediate value, test device. Now here, we're going to look at using positional logic to say it's going to get substituted with whatever arguments at position 1. So that will be this end device will then get substituted here. Jump if equal, star -3, so we'll just go back. Read device, oh, now we're going to use end device again, like that. Then the compare register, jump if equal, and now we're going to store this character to the second position, question 2. Second position is buff address. So we would then do the substitution here whenever we invoke this, so we can then store it at that buffer location. Do the text instruction, jump if less than, and then finally do a store index with this third variable here. Okay, then we have the mend, which is the macro end, and then the define table, we can continue storing additional things in there as well. But we're going to use the name tab here to hold these symbol names, and now it's going to have these pointers to the start and to the end of the macro definition inside of the def tab, the define table. Okay, arg tab, as I mentioned before, is the third data structure we would use, and that would then hold, in this case here, the 3 arguments that we are going to be passing to the macro every time we invoke it. And so symbols 1, 2, and 3, 1, 2, and 3, position 1, position 2, position 3, can then be called with different arguments, and they get mapped back to those addresses. Questions? Got it. Okay. All right, so let's see what happens then when we do the macro expansion using this example here. But answering a question somebody brought up last week saying, can we nest our macro expansions? And the answer to that is, yes, you can. And you have to be, of course, careful about the scoping rules while you're doing the expansion, but that's going to be pretty, I'll say pretty straightforward, but you do have to pay attention to it, because when you're doing the symbol substitution, it's going to be depending upon what level of the nesting that you're working with, so that you'll know that you've got the right set of symbols that you're working with in the macro processor expander. Okay, so in this example here, okay, we define a macro called macros. Okay, and what we're going to do is we're going to create a couple of macros within this macro, and there is the associated macro end for macros. Okay, and it just turns out that the first thing we wanted to do once we got into this macro, is to call additional macros, or define them first, because we're going to then expand them. So the first one will be the read buffer. Read buffer, we're defining a macro here, and we're going to have 3 arguments that we're going to pass to it. So there'll be position 1, position 2, position 3 like this, and then whatever code, and then we have the macro in for macro read buffer. We then want to do the write buffer. Kind of makes sense, right? Read a buffer from a device and then write the buffer to memory. Standard data throughput. So we have the write buffer, define the macro, and now it's out device, buffer address, and rec length. So you notice that buff address and record length are the same. The only thing that's different is input device and output device. And then whatever code we need to do that work. And then there's the mend for that macro. And we could have other stuff in here too. It could be another macro, or it could be some other work that we wanted to do after we read a buffer and wrote a buffer and do some other things to it if we wanted to. And then we got to our macro end. So that is all fine. That is perfectly valid, because what we have to do, of course, is that once we get into this macro here, which didn't take any arguments, it could have. We just didn't write this particular macro to have any arguments, which made it really easy then to manage working with these three symbols that's substituted at macro expansion time, and then another three at following that particular macro. Pretty straightforward. Okay, and the same can be done in the XE version of the machines. The assembly code is the same. There isn't any difference to the macro processor between the SICK Basic or the XE version. The amount of work might be less in here because you've got XE instructions, but that's the only thing different. All right, so now let's talk about, again, still in the discussion of nested macros using the macro definition define and expand. Okay, we saw that define is going to define it, create it, and expand will allow us to be able to do an expansion at that point. Interestingly enough, because we're doing nested macro definitions, we could be in the middle of an expand that actually invokes a define, which starts scratching your head when you say, well, wait a minute, we're talking about a one-pass macro processor, right? And the answer is yes, because remember, we're programming the expand and the defines, and so we can do that still while we're doing the macro expansion. It just means that we have to be careful of this, of maintaining what state we are in, so that we have the right symbols, and then we are able to exit to the next instruction correctly. Okay, so macro definitions, we can define a macro, then we can call a macro, do the expansion. We're still going to use name tab, define tabs, and arg tabs as needed for doing our expansions. We'll still call get line and process line, where process line now is going to be a little bit different than what we saw before. Get line is going to be the same, but process line is going to call on a macro, call define, and do that work. And then when you do an expansion, you're going to call the expand. But now, because the expand can include a define, the definition also has to be able to call process line recursively so that it can then get that next level. Let's see how that works. Okay, so we'll modify this pseudocode here a little bit to take a look at how these might be modified to work. Let's first start at the top where we're doing a define. So when we're doing a define, we call define. What we're going to do is we're going to enter the name into name tab. We're going to enter the prototype into define tab, right? That's where we've defined what it looks like. Now notice what we do here. We're going to set the level to -1. Okay, and then while level is greater than 0, so we are greater than 0 right now, right? Okay, we'll just go in. So level is greater than 0. Call get line. Okay, if this is not, as long as this isn't a commented line, in other words, it's actual source code or to include macro code, then substitute your positional notation parameters. Number one, get your new symbols and do the substitution in code. Enter the lines into the define tab. Now you're going to test to see if you're doing a macro definition. If you are, then you're going to increase the level by 1. Okay, so you're in a macro, you've now increased your levels. You've gone from level 0 to level 0. Then the next one will be level 1 and so on. Okay, so that's all we're going to do is simply do that. However, we got to be careful about, we could be in a macro because we are recursively calling ourselves here. If the opcode is min, macro end, then we want to decrease that level. We want to jump out of this level back up into the level above it. So as you can see here, this is how we're tracking the state of our macro processor by using these levels. Pretty cool, huh? All right, so now let's take a look at the expand. That's where it gets a little bit more interesting. So in expand, what we're going to do is we're going to say expanding to true, and then we're going to get the first of our definition lines from the define tab, set up the arguments by going to the arg tab, so we could do the replacement for symbol 1, symbol 2, symbol 3, or whatever we have defined in our particular macro program. And then while we're expanding, okay, and we're not at the end of the macro definition, call get line and process line. So that's what we're going to do. So we're just going to keep getting these, and we're going to keep doing the same thing over until we get to false at the end, right? When there's no more lines to get, we've broken out of our macros and we set it to false, and we exit. Get line, pretty simple. If we're expanding, then get the line in the macro definition from define tab, substitute the arguments, and repeat until you're done. Then you just get the next line from your input file and process that as usual. Okay, and it's just going to do this over and over again. So by doing this, we've been able to create a state machine, a very small state machine, but it's all we need because we don't need anything too complex to be able to track something that's pretty flat like a macro processor that is only doing 2 functions, and being able to track which level it's in so that we know what state it's in. So we've got that point, we're substituting the correct arguments, okay, that we were doing in the expansion for that level that we were in. Any questions so far? Okay. So here's another way to look at this, where we have the macro processor. We were just looking at from the code we were just looking at, right? We're going to set, initially it's going to be expanding is set to false, and it's going to call get line and process line. Get line, it's get line for source codes, just course source code. But if we get into a macro, we're going to then process a line. And at that point, oops, got ahead of myself here. Then process line is going to look and see if it's a define or expand, right? If it's a define, you're defining what it is. You call get line until you got to the end of the macro definition, and you pop back out. You come back to process line, returns. If, however, you are invoking the macro, you want to expand it, then you would call expand function, you would set expanding to true, and then you would call get line process line, just like we saw. So you can look and see, hey, is everything at this level, or is there a nested macro within this macro? And then you just do this same routine again, setting the level variable accordingly. Once you finish that, you come back to process line. Once process line's done, you go back to this get line process line routine here. However, get line at this level can also call get line, right? I'm gonna hear myself. In this case here, it simply would test to see if it is expanding. If it's false, then you're just reading that file. You're in source code, you're not in a macro. However, you could be reading a flat macro, which in that case, you're just pulling that macro definition out of the def tab, doing the expanding on it, and then returning. Right? So this is what we had seen before. And then we added this to support the nesting of these macros. Okay, so now let's look at what would happen if we did this as a two-pass algorithm. So the first thing we want to do is summarize what we know about the single pass then, and then we'll kind of do a compare contrast and look and see how we would do that. So in a single pass macro, every macro must be defined before it's called. We saw that. One pass processor can alternate between doing define and expand, right? You didn't have to do a strict alternation. You can do definition, 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 then expand, and then another definition, expand. You can mix them up as long as you defined every macro before you used it. And then the nested macros may be allowed, but you can't call them when you're nested because you can't break out of that level. So let's take a look at the two-pass algorithm then. So in pass one, we should be able to recognize all of our macro definitions. Okay, if we force that as pass one, now we might be able to do something a little bit differently, something more interesting here. Let's just say, what if we defined it this way right now and seeing if this has any value for us. So in pass one, let's say we'll recognize all of our macro definitions. So we'll do all the macro defines right there in pass one. Then pass two, we'll recognize the actual macro calls and doing their expansion at that time and substitutions. So if we do it this way, we kind of restrict ourselves by saying all the macro definitions have to be done first before we can call them. There really is no way for us to then mix the two up, which is what we're doing when we're doing a nested macro definition. So if you saw the code back here, if you recall the code back here, going back here a little bit, right? We had defined macros, and then we had defined read buff and write buff before we finished defining macros. So we started defining macros, then we started and ended read buff, started and ended write buff before we finished defining macros. So if, given this kind of topology and the sequencing here, we would have to have defined read buffer outside of this macro before we could call it. So we can't really support nested macros because we can't write them that way if we're going to do a two-pass macro processor. So nested macros, can't support them in a two-pass. And it's probably worth saying that there are still benefits in the sense that you don't have to worry about states, right? Because there's no nesting, and so you don't have to worry about that state machine. So you're going to have a very simple macro processor that way. It's more simplified, and there's things to be said for simplification. It reduces the likelihood of errors, but it also doesn't get you the complexity that sometimes you need. So not having the nested macros restricts you in that you would then have to define all of your macros first and then use them in sequence, in order, instead of being able to do that nesting operation like we'd seen. So that's kind of the trade-off there, simple versus more complex. We're also, of course, since we're doing a two-pass algorithm, it would have to be a two-pass assembler. We couldn't do it in a one-pass assembler. If we had looked at that, which we will do later on in another chapter, we'll take a look at the algorithm for the assembler in more detail and talk about one pass versus two pass and address that. But for now, this is really all we need to know about the macros, is that, yeah, if we do it in a single pass, we can actually get that level of complexity. We can also do it in a single pass, and that's usually a good thing. And the additional complexity is not that bad. It's pretty straightforward to implement. So yeah, probably worth doing. And that's the way a lot of macro processors are built. But it's always worth to look at these things and do the analysis, because if you can't explain why something is more optimal doing it A versus B, then you don't really understand it and you're not making decisions based upon experiments and evidence. You're doing it on guesswork, which is not how we build our compilers and assemblers and macroprocessors. Another fun thing that we like to do with our macroprocessors is to actually create more complex symbol names. And this is typically something that if you've worked with database engines at all, you've probably already dealt with a little bit, coming up with symbol names that mean something is a lot of times is based upon patterns. And you might even have multiple patterns that you're trying to use when you're creating your symbol names or your variable names. And when you're generating them automatically, which is what we're talking about with macros, right? We're using automata here to do these symbol naming and replacements. Then we might want to let the macro processor have the ability to create these unique names a little bit more creatively, if you will, so that we can have meaningful symbol names for us. So that's what this example here is talking about, this concatenation of macro parameters where we can take parts of a name and parts of another name and concatenate those together to come up with a name that's more descriptive of this particular macro. Because remember, we're defining the macro once, but we're expanding it many times. So when we expand it in our code, we may want to have like some sort of unique identifier saying, hey, this is my first time I've expanded this macro. This is the second time I've expanded it, or expanded it for this purpose or another purpose. And so you want to make that part of the symbol names that the macro is going to automatically create for us. And so that's what we're talking about here with this concatenation of parameters, is being able to give you the tools to be able to do exactly that. Okay, so in this example here, we're going to show you what things look like before we concatenate them, when we define them, and after we do a macro expansion and it does the concatenation. So first off, in order for us to be able to do this, we have to introduce some new terminology here. So that's what we're going to see right down here in this example. This very simple example here of this sum macro. So sum is defined as a macro meant to be these four functions here. It gets passed one name, one symbol name, and that's its ID, okay? And then what we're going to do is we're going to create names, symbol names, using just this one parameter that we passed. So load A, we're going to use, we want to prepend it with X, and then we want to add this symbol name that was passed when we called the macro and ID, and then we also want to append it rather, but that's what we use the arrow, and then notice we did this 1, 2, 3, S, okay? So that's what we'll do. So we'll have X, whatever was passed 1, X, whatever was passed 2, X, whatever was passed 3, X, whatever was passed S. Okay, so sum A then, what it will look like initially, load A. The first time we call this macro sum, we call it with a parameter A, and so X A1, X A2, X A3, X AS gets created just like that. Then let's say the second time we called sum, instead of being A, we want sum to be beta. So we called macro sum with the parameter beta, and now it's going to create X beta 1, X beta 2, X beta 3, and X beta S, just like that. So passing the one parameter, when we define our parameter substitution list like this, enables us to come up with more descriptive symbol names that the macro processor can build for us pretty simply. And then it makes it much more useful to us as we're debugging our code and we're working with our code later on, which is what writing code's all about. That's why we emphasize style guides when we're talking about our programming teams. We put together programming teams on these projects. We emphasize style guides so we can talk about naming conventions for our variables or symbols, and we can talk about much of other things as well. But this enables us, a very simple addition to our tool, our macro expansion tool like this, gives us that ability then, even at an assembler level, to be able to create meaningful symbol names that helps us write better code and debug our code and get better at this all the way around, which is the goal, right? Any questions so far? We've been covering a good amount of material here in macros. How are we doing? Pretty quiet group today. Okay. Okay, I think I'll do one more slide here and we'll talk about creating unique labels now. So from your textbook, you saw this example, you see this example here in figure 4.7, where we have these kind of situations here where we could use something like jump if equal star -3, which, as we all know, that says current pointer -3 going back one word, which is basically this instruction here, right? So we could do that. The problem is sometimes these get difficult to read, and we want to have better ways of writing our symbols so that they are much easier to see. Okay, so take this example here where we have something like loop, right? And we can call loop multiple times, this macro loop, and macro loop is going to do the same thing each time. It's going to do a test device for X, whatever device number we pass to it. So we want to be able to create that hexadecimal number that we're passing into this macro loop. Okay, now notice here that by using the $sign in the symbol name here where we're defining this macro, is that we're telling the macro processor here saying, hey, we want you to create a unique label for that symbol every time we invoke the macro, right? So the first time we defined it, it's going to get defined like that. But when we called it, let's say we called loop now, and if we called loop and we passed it F1, what would happen is it's going to prepend it, because we put this in this position here. We're going to prepend it starting with AA. That's when I say we, the macro processor, will prepend it. So it'll prepend it with AA, then the name we gave it loop, so we still know, oh, it's loop macro, but it's the first instance because it's AA, and we passed it F1, so now it's doing the single quote F1 in single quote, and so it would then substitute that. So you would then have hexadecimal F1. And then if you called loop again with F1, with open F1 open, the next time it would simply increment. It will keep track of how many times you've called loop, and it knows that it's started with AA because that's the convention that it will use, the macro processor will use for the times that the programmer wants it to uniquely label each instance of this macro invocation in this macro expansion. So the second time it would just simply increment AA, the next one would be AB, so AB loop F1, and then so on. If you called it a third time, it would be AC loop, AD loop, and so on. And then whatever parameter you passed it, we could have passed it a different parameter than F1 the subsequent time, and that's what would have shown up here. But at least this gets you the idea of these really useful tools for creating not only unique symbol names that we're using in the operand, but also the macro itself. So instead of sum A and sum B, we could have now done AA sum, AB sum, AC sum, AD sum, and then it would be very obvious to us when we're reading the code which one we are in. And it's really handy. It's kind of hard to see here because you're looking at this pretty flatly. We're just defining things here. But if, and we've also looked at very short examples of source code. But when you start getting into many pages of source code, and you're doing these macro expansions, you don't want to always have to go back to the beginning to say, okay, where did I define it? And okay, I need to see where I defined it, or go to the def tab. But then how many times have I invoked this thing? You know, is this my 14th instantiation? Is this the 26th instantiation? You know, it's going to be obvious when you're using a unique labeling scheme like this that, oh yeah, I've used this. We're now up to SC loop. You know, we've invoked it 20, how many times? I forgot how many 26 times S is. Should have used a simpler example. And then that way you'll know when you're looking at that macro expansion that this one is separate from the previous one and you've invoked it many times or a few times or whatever, which is really helpful when you're trying to debug code at the assembly level, because things are kind of spread out because you're not writing in a high level language, of course, and so therefore lots of instructions per single line of high level code. It makes it very important to think about those kinds of tools that you need to be able to debug your code and write it such that you can debug it much more simpler than you are used to doing at the higher level code. Okay? So any questions? I think I want to stop here, just take any additional questions we have before we sign off here. And then what we want to do is we want to finish up this chapter on Wednesday. So questions you have now, that's good. Okay, so Ivan has a question. What is the difference between subroutine and macro? And I can answer that, but I guess I'm going to first ask if somebody else wants to take a try at answering that. If somebody else thinks they have a good way to describe that. No brave souls? Really? All right. Well, let's think about it from a couple of different, oh, Jacob, Dante, okay. Okay, Jacob.
Hello? Can we hear me?
Yes.
Excellent. So isn't the major difference that a macro is more of a symbol table or externally defined function or operation, and then the subroutine would be something within your respective program that you loop back to?
Not quite, because they're all code, right? So both subroutines and macros are going to generate code. The biggest difference is that the subroutine, that code is going to exist once in the actual object file that's generated, as well as the source code file that's generated as an interim file. It's only generated once as a subroutine, but every time you do a macro, you're going to rewrite the code. You're expanding it to include all of those instructions every time you invoke the macro. However, the advantages now that you're seeing is that that might be true, but you can also work with different symbols, multiple different symbols, and be able to have much more flexibility in the operations that you would do within the macro that you're somewhat limited in doing in the subroutine. Although remember, subroutine doesn't really have the same scoping rules that you're used to with functions and methods, because it can still see all the and access symbols around it. So it can, it's just not as obvious as, and it's not tightly controlled, which, and if you haven't caught that yet at assembly level, it is not tightly controlled at all. That's one of the things that we need with assembly code, is the flexibility to be able to go in and just modify any of these things. Does that make sense?
I understand. Would a reasonable analog be? It's the difference between a shallow copy and a deep copy.
It would be similar. I don't know if I like that analogy too much, but it would be somewhat similar.
That's fair. Thank you much.
Yeah. Other questions? Okay, I think we'll go ahead and call it a night. And like I said, Wednesday we'll get together here and we'll finish off our discussion here at chapter 4 and get ready for a break next week. All right, thank you.